Unit 5A, Lesson 6. In this lesson, we're going to talk about two types of measurements for angles created in circles. We've talked about degrees in the past. We're going to learn about radian measurements and how to convert from one form to the other. We're also going to look at finding arc lengths of circles. And then at the end, we're going to work with a formula for finding the area of a sector of a circle. So first, we're going to talk about radians and degrees. We know that a circle has 360 degrees, so if we're talking about an angle formed in a circle, it's going to be between 0 and 360. If we're talking about radian measures, it's going to go from 0 to 2 pi radians. Okay. The way we could tell the difference between degrees and radians, well, one, degrees are going to have a degree symbol. A radian does not have to have any symbol corresponding with it. Also, if there's ever a pi associated with the measurement, that's a good indication that is a radian measurement. Now we're going to work to convert between radians and degree measurements. So the basic idea is if you want to convert from one form to the other, you're either going to multiply by pi over 180 degrees or 180 degrees over pi. If you're trying to convert it from degrees to radians, you're going to multiply by pi over 180. If you're trying to convert from radians to degrees, you're going to multiply by 180 over pi. So whatever measurement you want to end up with is going to be the value that's in the numerator of the fraction. For instance, if I wanted to convert to radians, pi is a radian measurement, that's going to be in the numerator. If I want to convert to degrees, 180 degrees is our degree measurement, so that's going to be in the numerator. So down below we have 60 degrees. We want to convert this to a radian measurement, so we're going to multiply by pi over 180 degrees. Now we want to look to simplify this. This is the same as 60 over 1. I'm looking at the numerator and denominator, seeing if they have any factors in common. 60 and 180 have 60 in common. So if we take a 60 out of each of those, we're left with a 1 and a 3. So now if we simplify, we have pi over 3 radians. So 60 degrees is equal to pi over 3 radians. Now on the one below, we have 4 pi over 3 radians. We want to convert this to degrees, so we're going to multiply by 180 degrees over pi. Now looking to see what simplifies, we have a pi in the numerator, denominator that cancels out. We have 180 and 3 that will simplify again. 3 goes into each of those, so in the numerator I'm left with 1 and 60. So now if I multiply 4 by 60, we get 240 degrees. So 4 pi over 3 radians is equivalent to 240 degrees. Next, we're going to talk about arc lengths. The formula to find the arc length is S equals R times theta. S represents the arc length, R represents the radius of the circle, and theta represents the angle measurement. The thing to remember about this formula is that theta must be in radians. So if it's in degrees, we have to convert it to radians, just like we went through in the previous part. So to see what the arc length is, if we look at a circle, if we have a radius and our angle theta between those two radii, the arc length is the portion on the outside of the circle that is contained within those two radii. So this would be our arc length. So now we'll go through an example of finding the arc length. Suppose the radius of the circle is 4 units and theta is 120 degrees. So now we just got to plug values into our formula to solve for S. Before we can use the formula, we have to convert our angle measure into radians because that's what the condition is for this formula. So we have to take 180 or 120 degrees, multiply by pi over 180 degrees to convert this to radians. Now if we look to simplify, 60 goes into each of these. So this simplifies down to a 2 and a 3, leaving us with 2 pi over 3 radians. So 120 degrees is equivalent to 2 pi over 3 radians. Now we can use our formula. S is equal to 4 times 2 pi over 3. Now multiplying those values together, 4 times 2 gives us 8 pi over 3. Eight pi over 3 is our exact answer. If we wanted a decimal approximation, you could just plug that in and you get approximately 8.37 units. Your label on the arc length is going to be the same as the label on the radius of the circle. So if your units were inches, your label would be inches. The last part of this lesson is going to involve finding the area of a sector of a circle. The formula we're going to use is A equals 1/2 times r squared times theta. R is the radius of the circle, theta is our angle measure, and the same as the last problem when we talked about arc length, theta must be in radians. So if that measurement is given in degrees, we first have to convert it to radians. So if we're looking at a circle, a sector is formed by 2 radii. So we have the first radius and the second radius, our angle theta that is formed. So we're looking for the area of this sector, this part of the circle. So you think about a piece of pie or a piece of pizza. In this case, you would be looking for the area of a very large piece of pizza. So an example, if we want to find the area of the sector formed with the radius being 6 inches and our angle theta being 3 pi over 4, this is already in radians, so we don't have to convert it. So now we just plug it into the formula. The area is equal to 1/2 times our radius squared, which is 6, so 1/2 times 6 squared, times our theta measurement, the angle, which is 3 pi over 4 radians. So if you would simplify out, 6 squared is 36, half of 36 is 18. So if you take 18 times 3, you get 54 over 4. 2 goes into each of those, which is where we get 27 pi over 2. So the area of this sector would be 27 pi over 2 inches squared. Talk about area, so our label has to be squared. And if we would type that into a calculator, you get approximately 42.39 inches squared. So that would be the portion, the area of this sector that was formed. So that would be a fairly large piece of pizza.